Hi everyone, Miss Kirchgessner, your math teacher again. We're going to talk about functions today. A function is a relation between numbers where every input has exactly one output, right? So I like to think of a vending machine. Imagine you and your friends are out dancing and you are thirsty, so you want to stop by the vending machine for a root beer. So you push A1 and you get your root beer. Your bestie says, oh my gosh, I want that root beer too. It looks great. So she pushes A1 again. But instead of getting a root beer, she gets pretzels, which is the opposite of hydration. She gets a bag of salty pretzels and you've got your delicious Barks root beer. Now, that is a broken machine. That is not a function. The x's cannot repeat, right? You can repeat the y's, you can repeat the outputs, but you cannot repeat the x's. Don't look at the y's when you're answering these, just look at the x's. Now, brought up this question to you because I'm going through all of the last 10 years released test questions for this Algebra 1 EOC that we've been talking about all the time. And this is the question that comes up a lot, the most, I think, from this standard. Determining whether something is a function from a graph, a list of ordered pairs, a table, and knowing all the different ways to spot a function no matter what information is given to you. So let's have a look. So we're going to select all of the relations that represent a function. So let's look at card A. Card A has, oh, and I want to tell you, don't even look at the y's. Only look at the x's. Only look at that x column. Don't look at the y column at all because it's going to mess you up. Let's look at card A. In card A, 0, 4, 5, 7, and 7 are the x's. In card B, 0, 3, 6, 9, and 15 are the x's, right? Which of those is a function and which is not? Exactly. Yeah, we see that these 7s repeat, right? This person pushes 7 and then they get a root beer. They push 7 again and then they get a Sprite. Not cool. So A is not a function. B, we choose B. C and D, we have tables, right? So we just chose what was a function from a list of ordered pairs. And now we're going to choose the same from two different tables, which is like a list of ordered pairs just set in a different way. We have our x's here. Don't look at the y. Don't look at that y column. Just look at the x column because those -3s repeated, those are going to mess you up. 0, 4, and 7 are the x's here. 4, 4, and 4 are the x's here. So which one do you think? Yeah. Card C is the function for sure because 0, 4, and 7 do not repeat. Cards E and F. Now, if I have a vertical line and I'm moving it from left to right, like let's say this, sometimes I like to hold up a pencil and kind of move it across the screen from left to right. This guy, this like little S, sideways weird S, is only going to pierce that pencil at one point as this pencil moves from left to right across the graph. Let's look at card F. This is a quartic that has a index number of 4. If something was like x to the power of 4, this is what it would look like. Anyway, if I'm dragging my pencil from left to right, this quartic function is only going to pierce my pencil one time as well. So let's choose both of these because those are both examples of functions. Those both pass. But what wouldn't pass would be like a circle, right? Because a circle would pierce through the pencil 2 times. Anyway, so let's lock in our answer and see how we did perfectly. Here is just like a quick breakdown of why each card won or lost. A common trap: do not reject a graph because it looks complex, right? Don't say like that quartic function that was like a big weird wiggly W. That's a function. It looks weird. It's x to the power of 4. We don't know about quartic functions yet, but it is a function because it does not pierce the pencil as it moves across the page more than once. Anyhow, please don't hesitate to reach out if you have questions about this or anything in this class ever. And I love you all and hope you have a wonderful day. Toodles!